Hi, today we are going to classify images using a vision transformer. So we will take this image, for example, of a Shih Tzu dog, and we would like to predict this class, this specific class of a Shih Tzu dog, not only a dog, but also the specific kind of dog, the Shih Tzu dog. So in order to do that, we are going to create a Conda environment and install all the requirement Python libraries. So let's create a Conda environment. Let's name it Feit16 and we will use Python 3.8. During the installation, I would like to elaborate that the Vision Transformer model was pre-trained on ImageNet 21K. That means that it was trained in order to identify and detect 21,000 classes and over 14 million images. This model can also be fine-tuned for the common practice ImageNet, which has the ability to detect 1,000 different classes. So you can see during the installation that we already are inside the Feit16 Conda environment, and we are installing several Python libraries like transformers, OpenCV, and Pillow. Next, we are going to install PyTorch, but in order to do that, we have to find our CUDA version. So we will run nvcc ---- version. You can see that my version is 11.8. You can find your own version. After finding your version, go to the PyTorch website. Look of all the relevant versions. You can see the last one supports 11.8, but let's see the previous one. As you can see, version 2.1.2 supports 11.8 and also 2.1.1 support 11.8. Let's go. As you can see, 11.7 for example is supported with version PyTorch version 2.0 2.01. Okay, let's copy this one. I'm installing PyTorch 2.20. Okay, it may take several minutes. Let's jump directly to the final step. Right. Okay, let's install the last one, the charded, and I think we're done. And now we can continue with writing some code. Okay, let's jump directly to the VS Code. Here is the install file. I will leave a link in the video description to all the code. Let's change our environment to our new Conda environment, the Feit16. And now let's look at our image. This would be our image that we would like to classify. I will leave this image along with the code so you can use it as well. And let's create a new Python file. Let's call it classify image from the Coco dataset. Okay, let's start with some importing. We will import from the transformers, we will import the extractor, the feature extractor, and the Feit for image classification. I explained about it later. Let's also import some image functions and also the OpenCV. Now let's load our image. We'll use OpenCV in order to load it. Okay, and now since OpenCV is based on BGR, we would like to convert it to RGB since our model was pre-trained with RGB color images. So we would use the CVT color function in order to convert the image. Next, we will initiate the Feit feature extractor and the Feit for image classification model in order to use our pre-trained vision transformer model. We will download it from Google. This feature extractor performs tasks such as resize image, normalizing pixel values to convert them between 0 to 1 instead of 0 to 255, and also applying any other necessary transformation to prepare the import for our Feit model. The next phase is loading our model. In order to do that, we will use the Feit for image classification since we are going to classify images, and we will set the same argument as for the feature extractor. Okay, next we are going to use our feature extractor, and we would like to extract the feature out of our image. So we will run this feature extractor and send two arguments. One is our image, and the second one is the return tensor PT. This return tensor PT means that this parameter specifies that the function should return a PyTorch tensor. Basically, this image the processed image is returned as a tensor suitable for our input to the PyTorch model. Great, let's continue. So this is the inputs. Now let's deal with the outputs. The model basically is the instance of our Feit for image classification class, representing the vision transformer model for image classification. So the inputs contain the pre-processed image data. The double asterisk syntax is used to dictionary unpacking and passing the content of the input dictionary as keyword arguments to the model. So the outputs contains the results produced by the model, and the logic attributes typically holds the raw scores for each class before applying any activation function, for example, softmax. So now we can use this logic variable in order to make the predictions and extract the highest value. So we will use the argmax in order to extract the highest value and get the predicted class index. Okay, this is the syntax in order to get this index. So let's print the index and see what is the class. I have a syntax error in the cvt.cv2 color. I hope you fix it, and also it should be returned tensors. Okay, after running, as you can see that the index is 155. So what is basically class 155? Let's find out. So in order to do that, we need the class name. So the model has another attribute under the config called ID to label. So we can run this attribute and grab the class name. Once again, let's print the predicted class name. Let's run it again. So as you can see, it's 155 and the predicted class is Shih Tzu. Great. So now let's add this predicted text to our image and show them together. So we would like to see as a result the Shih Tzu image along with the predicted class name. So we will use the put text function from OpenCV. We can choose the color and the name and the position of the text and the font, and we will use the IamShow in order to present and display the image, and the wait key for wait for the keyboard. So let's run it again. Great. As you can see, this is the text and this is the image. I hope you enjoyed this tutorial. You are most welcome to subscribe. Bye bye.